All right, welcome everybody. I'm going to present to you Acurast pioneering zero trust universal interoperability. I'm Christian Killer. My background is in blockchain voting, so I focused during my PhD on cryptography, privacy, verifiability. So all of these hard problems that we also have in the adversarial landscape of blockchains. So we have a very similar setting in voting that we also have in blockchains in general. So how can we actually interact with these systems, minimizing trust, and essentially going towards a zero trust future? Just quickly outlining the motivation behind Acurast in general. So normally when we design a blockchain, we have a trilemma. We try to optimize decentralization, security, and also scalability. We sort of agreed on that and said this is a trade-off, but in my opinion and in our opinion, this is not sufficient. So we also need to have effectiveness of computation. So with all of these improvements that, for example, Polkadot is also making in scaling up, we also require confidentiality on the execution layer, for example. Because if everything is public on a blockchain, as we all know, this might be good and useful for some use cases, but then essentially working on private data can be enabled not only with zero knowledge proofs, but also through secure hardware. So the problem space that we move into together is like decentralization of infrastructure, which we can also see nowadays in most of the blockchain projects and also throughout the internet in general, is that essentially all the cloud providers are the backbone of all the applications that we run today. This is a huge problem because it's not censorship resistant and it's logically not decentralized. So with Acurast, we have a decentralized layer 1. How this exactly works and why it's good or better than other approaches, I'll outline in the next few slides as well. How do we tackle the lack of confidential computing? We have a confidential execution layer. We'll also go into deep on that, because there we can show you actually how this zero trust architecture actually achieves more confidentiality and also more effectiveness in the computation. The third problem we have is all these trusted auxiliary systems, essentially the Oracle problem that we always face when we build something more advanced on a blockchain, because you always require some data from outside, or you want to transfer some data somewhere else. You have information exchanges, price feeds, etc. So how we approach this is really by minimizing trust assumption on every layer. And last but not least, interoperability. We have lots of different fragmented ecosystems, and also today we saw lots of different talks on this issue in general. And we have an approach that we call universal interoperability, which not just interoperates Web3 to Web3, but also Web3 to Web2 and vice versa. So you could actually use our infrastructure as well to build a decentralized web application or AI application. We believe the future of Web3 is in universal interoperability, and lots of developments also show the potential of just interconnecting all of these systems together. And as I mentioned before, this is not limited to chains, but also Web2 or IoT, for example, for supply chain tracking, which has been tried many times before, and it oftentimes fails in the execution because you introduce some trusted third party or some protocol that is not appropriate for the use case. So this is the Acurast universe where we interconnect all of these systems together, and how that works in detail, I'm going to outline the next few slides. We traditionally have this monolithic approach where a chain, of course this differentiates from chain to chain, I'm aware of that, but simplified, we have like consensus, settlement, and execution in one software module. Sometimes this is split up, but at the end of the day, you have it on a single server, if you're a validator, for example. So we kind of separate these architectural layers by having a permissionless consensus layer, which serves as an orchestrator, where computational resources are matched to consumers. So consumers want to, for example, create a price feed, and then they're matched to processors that run this inside of their execution runtime. As of today, you can already deploy on the Acurast secure hardware runtime, so meaning that you use a decentralized network of this secure hardware runtime that is running on external coprocessors inside of Google phones. How that works in detail, also a few steps ahead. And then you can settle actually anywhere you want. You can natively settle on a Web 2 system, for example, persist on an S3 database, or you can also use our universal interoperability layer to settle on another Web 3 system. So for example, initiate on Polkadot and then settle on Tezos or any other EVM-based chain. And on top, this remains more or less the same. We have the application layer, which then consumes this data. What is zero trust? Since it might seem like a buzzword, so I'm going to outline a little bit what we actually mean by that. So it follows like this paradigm that we all know, this ethos of Web3, never trust, always verify. And why is that from the bottom up? Ultimately, because we have a permissionless orchestrator. It sort of serves like a place where demand and supply meets. And in order to have a loop, a feedback loop, we have a reputation engine inside of there that assures that honest behavior is incentivized, and you can actually verify that trust assumption that you take based on the reputation engine's output, right? The second point is that we always want confidence through verification. In our case, that is deployed as of today on the Acurast Canary network, we have these secure hardware runtimes. Then we have a trust root inside of these devices that is based on Strongbox, where basically you cannot extract the key. And also Android verified boot that assures that nobody can escape this, this secure runtime. What is crucial to mention here is that this is not based on any virtualized trust execution environments like SGX or Trust Zone that is partially virtualized, but it's based on an external security chip, so a so-called coprocessor that is run like completely separate, and the private key cannot be extracted from that chip. What are the options as of today? So if you build a similar system or you try to approach this problem and you want to have confidential execution, meaning that nobody can read your data in motion or at rest or during computation, especially during computation now, that will mean you deploy, for example, in an AWS HSM, and then you have the trust assumption that AWS or any other cloud provider actually doesn't censor you, doesn't close your account, and you cannot really verify all of the steps there. You can deploy your own colocation. That's very easy, right? You can just buy a bunch of servers, some HSMs, and then set this up. Takes you just a few years to get around. So yeah, this is not really feasible for, let's say, the average developer. And also for the average budget that we have. This is where Acurast comes in. So if you want to achieve confidentiality, decentralization, and also permissionlessness, where on the execution layer, you can actually choose this way. Our goal with this is ultimately to lower the entry barrier for developers. So we really want to motivate you guys to try this out, because it's live since the 13th of September, which was Programmers Day, so a great day to launch. And we have universal integrations, meaning you can deploy on Substrate, any Substrate-based chain. You can deploy on a few EVM chains. It's also WASM compatible, and we have a bunch of L1s. Here, showing you an excerpt of the console. So this is the UI you can visit on console.acurast.com. And you can see here that we have Ethereum integrated, any Substrate chain, Optimism, Polygon, Arbitrum, Base, Binance Smart Chain, Moonbase, etc. I'm going to show you now one example end-to-end, how we can deploy a Oracle contract from Chainlink, so an aggregate interface for a data feed on Moonbase. That's the first step we do. And then we use Acurast to actually fetch the price data from Binance endpoint and then persist it on-chain on Moonbase. How this works, I mean, you could also deploy this differently, but for the sake of simplicity, we used Remix here. As you can see, we deployed it. Deployment is visible here. So this OXBEF is the smart contract address. After deploying it, we take note of the address. Always fun part. As a second step, we visit the console. So here we can select Moonbase. And then here you could see there's different templates. As of today, we just have a price feed and a verifiable randomness template. But you could write any script in there that is JavaScript V8 compatible. So really, your creativity limits you only, and also the V8 engine. But that's it. Then you define it exactly. Don't forget to replace in the price feed template the contract address, because otherwise it will simply fail. This is just an excerpt of the script. So as you can see, destination is the OXBEF contract, the API of Binance. And as you can see, in the response we have a certificate, which here for the sake of simplicity is not verified, but you could also integrate certificate validation inside of a job, which means that you can actually verify where's the data from. You could even add more certificates, your own certificates, additional steps, etc. You can also see the API of an RPC, could also be a different RPC, of course, and the method signature, which is fulfill. All of the EVM-specific gas limit parameters, and then just some error handling stuff. Right. So now the fun part about processors, which I didn't mention so far. Usually when you try to deploy a system that might be permissioned, you run into a problem, because you sort of want to leverage decentralized infrastructure, but you don't have the option to deploy a permission use case very easily. At the end of the day, you will introduce, for example, access control in a smart contract, but with Acurast you can actually run your own processor network and use them specifically for yourself. So you could build consortia, sub-consortia very easily on the execution layer, which is a huge benefit also for just testing applications or for applications that are decentralized but still have a consortia behind, right? Of course, you can also use public processors where you go through this public matching that I mentioned before in the orchestrator, or you can use your personal ones. So when you're logged in with your account, you can select your own processors directly. What was happening in the background while I was talking about processors was that we have execution schedules. So you need to define, is this execution, when is it starting, when is it ending, what is your max time delay that you want to accept. So when do you consider the delay to be not feasible anymore to run the job? And also you need to define a reward. Since we're on a test sort of developer net, Canary net, this is kept very simple, but in the future this will be extended with, of course, like gas estimations, etc., or reward estimations that need to be very to the point, and also there will be a market of processors fighting for demand, right, for consumers. Then you hit publish the job and wait for inclusion. So this is what the UI looks like of the console when you deployed your, deploy might be the wrong word, registered your job. You wait for acknowledgement, so you can see in the block explorer here that it has been acknowledged, 1 out of 1 processor acknowledged. So you could also say, I want 5 processors to run this job. So you could easily say 10, 100 processors, which in some use cases, in some algorithms, this makes sense. In our case, just to fetch a price and show the use case doesn't make a lot of sense. So now we will wait for the fulfillment, which in this case is a specific time that was yesterday. And you can see on the first few seconds, it was a bit fast. Here, right here, 16 seconds ago, the transaction was sent on this aggregator interface. And you can see also in the console, 1 out of 2 repeated executions. And now we're going to verify on Remix interacting with the smart contract that the data actually was persisted. So getting back the data point, which was 32, and also the Unix timestamp you can see right there. Right. So this was just a price feed, but there's, I know this sounds very marketing-like, but limitless possibilities with this, because in JavaScript you can build anything you want, right? So we see lots of different potential use cases that are really, really interesting, and they're being built as of today, already used as of today. So the price feed use case you saw is already used on Tezos. Also, verifiable randomness, quite hard to achieve. At the end of the day, I know there's the RANDAO and other approaches and different networks, but depending on your use case, you're really limited with the output you get. And here, you're just constrained by the V8 engine. As of today, and also in the future, will be WASM compatible, which means you can write your jobs in anything you want. Of course, off-chain data in general, a huge potential use case as well. Confidential computing, as of today, you have to trust to some extent cloud providers that they actually have their DevOps in place, and also the hardware is actually that they promise you. So in this case, you can verify this very easily with the root of trust of the devices. We can also have zero-knowledge execution services, so certain parts, depending on the proof system, Stark, Snark, different verification algorithms or generation algorithms, depending on if you have private input, make a lot of sense, right? Because generating and verifying proofs can be very time-consuming, and depending on your node, it also doesn't make sense to do this while, for example, building a block. So depending on the use case, zero-knowledge execution service can be really interesting as well. One that I'm really passionate about as well is privacy mixing. So you could build a mixnet for traffic, for transactions, metadata obfuscation. So all of that stuff that you have currently in separate networks, you could build this as well inside of a subnetwork of processors or public processors, confidential analytics, etc. So another interesting one might be the incorruptible sequencer. So different approaches exist as of today to counter front running, but you could also choose like a sub-consortia on Acurast. They then do the ordering, and you can actually verify and trust these assumptions that are zero trust. Wow, what a mouthful. But actually be sure that the execution was correct and done the way it should be. We really believe that as of today, mobile devices paved the way towards zero trust decentralized computation, but it's not limited. So in the future, we envision that you can not only provide computation and earn rewards with phones, but also could be cloud-based HSMs or zero-knowledge-based runtimes. So since we have this modular architecture, you can actually leave it up to the consumer and the processor on what they want to provide on the market, on the orchestrator, and also what they want to consume at the end of the day. As you can see, old phones can provide some second life to them by running Acurast processor software on them. And you can participate in the network with currently mainly Google Pixel phones. This is the roadmap ahead. So we had the pre-net launch, Canary network launch. So our goal currently is to onboard developers and processors. Then collators, of course, have to be onboarded for a decentralized layer 1. And then in Q1 24, that will be the case. And also token transfers will be activated. As of today, they are deactivated. And we still have Sub0, so it's experimental. Stop overthinking, start building. So invite you all to visit the console, join the community, of course, and check the documentation. And if you have any questions, you can catch me outside later. And also now, feel free to ask anything. Thanks. Any questions?
Thank you, Christian, for this presentation. Is there any question from the audience related to Acurast and its solutions? Everything was clear?
All right.
Okay. Yes, so thank you. Thank you again. And now Now this is the time for turn network. It's already finished, no?
Okay, good. Thank you.
No? Is it finished?